Okay, so this is our last video for section 4.6, and we're going to start talking about how to calculate these limits at asymptotes. Okay, so these are things that cause division by zero. So I'm back to this function that we looked at the graph for in the first video. As x approaches 3, this is where the graph was splitting off and having these huge y-coordinates. Okay, and so now we want to talk about how are we going to figure out that the y-coordinates are going to infinity or negative infinity without Desmos sitting there graphing it for us. Okay, so let's take that function and get a blank sheet of paper here. All right, so if we want to go to our limit, dang it, come back here. As x goes to, let's see, 3, we'll just pick one from the right or the left. 2x minus 1 over x minus 3. So we were just looking at that graph and we know that it was infinite on that right-hand side. Okay, so when I try, ignore the plus for a minute, just plug in 3. We'll try the same old trick plugging in. So I plug in 2 times 3 minus 1 over 3 minus 3, and I get 6 minus 1 is 5 over 0. Okay, so now back in section 2.3, if we had 0 over 0, that was a trick, right? We had to use a trick like factor and cancel or rationalize or something like that. That meant we needed a trick. When you get a number over 0, okay, that means you stumbled on a vertical asymptote. So those limits are always equal to infinity or negative infinity because the graph is going to have that behavior where it's going to either be going to infinity on one side and negative infinity on the other, or it might be going to both positive or both negative infinity. Okay, so how we're going to figure that out? Okay, so you get this number, 5 minus 0. Okay, let's get rid of that graph. So we don't know if it's going to be equal to positive or negative infinity because we don't know what the graph looks like. Okay, so all you have to do is figure out what is happening to 2x minus 1 over x minus 3 on the right-hand side of 3. So draw yourself a number line. Okay, so here's 3. We're taking the limit as x approaches 3 from the right. Okay, so we are over on this side we're taking the limit over here. We're on this side of the x-axis. We're on the right-hand side. All right, so let's just think about what's happening to 2x minus 1 over x minus 3. Okay, so we know that if we take a number that's really, really close to 3, like 3.1 on the right-hand side, okay, then 2 times 3.1 minus 1 is going to be something positive, right? I don't know exactly what that is because I don't have a calculator, but I know it's going to be positive. But then think about x minus 3. If I do 3.1 minus 3, that is also something positive and small. Okay, so I know that because I got 5 over 0 up here, that the answer either has to be infinity or negative infinity. But because on the right-hand side of 3, this fraction is always equal to a positive thing over a positive thing, we know that it's going to be positive infinity. And we saw that from the graph, that on the right-hand side of 3, it was equal to positive infinity. Okay, so now let's look at that same function from the left. Okay, I know the answer from the graph was negative infinity, but let's see if we can figure it out. Okay, so if you didn't know what the graph looked like, and I gave you you would start by plugging in, okay, 2 times 3 minus 1 over 3 minus 3. You would end up with 5 over 0. Okay, we know that's either got to be infinity or negative infinity. Again, 0 over 0 means do a trick, get that removable discontinuity to disappear. A number over 0 means you found a vertical asymptote and your limit's going to be infinite, either positive or negative. Okay, so now we're looking at, we're going to make ourselves a number line. Here's 3. We are on the left-hand side of 3. This is x approaches 3 from the left. So now we're over here on the left-hand side. So we're going to pick something like 2.9. Okay, something that's very small distance from 3, but on the left-hand side. And then we're going to think about what happens to 2x minus 1 over x minus 3. Okay, 2x minus 1, if I plug in 2.9 up here, 2 times 2.9, that's way bigger than 1, so this is going to be something positive. But now on the bottom, 2.9 minus 3, that's actually going to give you a negative number, right? Something smaller than 3 is going to give you a negative number. Okay, so on the left-hand side of 3, very close to 3, you have a positive thing over a negative thing, so you know this limit is going to be equal to negative infinity. Okay. All right, so we use this sign test, this number line test, when we are very, very close to something that's giving us a number over 0. All right, so let's see. What do we want to do? Let's try another one of these. All right, so let's take the limit as x approaches 4 from the right, 6x over 4 minus x. Okay, again, all of our limits, we're always trying to plug in first. We're trying to see what's happening. So if I plug in 4, we kind of forget about it being 4 from the right. I just plug in 4, and I get 24 over 0. Okay, so anytime you get a number over 0, that means your answer is either infinity or negative infinity. All right, so we need to set up a number line and figure out which one it is. So here's 4. We're taking the limit as x approaches 4 from the right, so I'm on the right-hand side of 4. So you're going to pick something that is just to the right of 4, 4.1. I mean, you can pick something like 5, but you want to get really close to 4 just in case it's a weird function that changes its mind once it gets far away from 4. Okay, so I'm picking something very close to 4, and I'm asking myself, what's happening to 6x over 4 minus x? Okay, 6 times 4.1 is going to be something positive. Because remember, we don't care exactly what the number is. We're just trying to decide between a plus infinity and a minus infinity. So that's why I'm doing a sign test. Okay, and then 4 minus x, 4 minus 4.1. 4 minus 4.1 is going to be something negative. All right, so positive divided by negative, that means this limit is negative infinity. Okay. Okay. Let's do one more. Let's take the limit as x approaches square root of 5 from the left. Square root of 5. And our function is negative 2 over x squared minus 5. Okay, as usual, I'm going to plug in. Again, forget about the left hand or the right hand. We'll just see what's going on. Negative 2, there's nothing to plug in there. Square root of 5 squared minus 5. Okay, here's where the square root of 5 came from. It's what makes this denominator equal to 0. Square root of 5 squared is 5 minus 5. You get negative 2 over 0. And again, 0 over 0 means a trick. Number over 0 means infinity or negative infinity. It means this is a vertical asymptote of this function. All right. So, yeesh. This is going to be harder to do because I've got the square root of 5 here. I don't know what the square root of 5 is. We don't have calculators, and so, I mean, it's something between 2 and 3, right? 2 squared is 4, 3 squared is 9, 5 is in between 4 and 9. Okay. Well, okay. We're not going to even think about an actual number to plug in. Let's just think about, we're taking the limit as x approaches root 5 from the left. So I'm over here on the left-hand side. Okay. So I'm going to see what's going on with negative 2 over x squared minus 5 over here. Okay, so negative 2 is negative all day long. Doesn't matter what I plug in for x. The top is always negative. On the bottom, x squared minus 5, okay, when x was equal to the square root of 5, x squared was actually equal to 5. But if I take something over here, it's going to be slightly less than root 5. Okay, so something slightly less than root 5 is going to be smaller than 5 when I square it here. So you're taking something smaller than 5 minus 5. That's a negative thing. All right. We also said if you need a concrete number to be plugging in, we said, let's see, like we said that root 5 has got to be bigger than 2. Right, because 2 squared is 4. So you could plug in 2. 2 squared is 4 minus 5 is negative 1. Okay. So we get a negative over a negative. That's going to be something positive. Okay, so we know that we're going to choose our positive infinity here. All right. So anytime you get number over 0, you're just going to do a sign test to see what's going on. Is the answer positive or negative? Because anytime you have a number over infinity, it's a vertical asymptote. It's headed towards infinity or negative infinity. All right, so that's the end of 4.6. You should be able to get through that homework now. Let me know if you have any questions.